Hello guys, welcome to Ramta Solutions. Welcome to your lesson on grade 11 trigonometry. Today we are looking at identities. So in this video, we are going to give you a scope of what identities are, even though it's not really much of a big deal. And then we're going to give you quotient identity, which is one that uses tangent relating to sine and cosine. We are also going to derive the square identity, which is the square of sine and the square of cosine. These are this is the information that you're seeing in this opening slide. Okay? And then we are then going to try some examples. Okay, so now when we talk of identities, basically this is where we are equating the left hand side and the right hand side. So shouldn't really worry much about what they are. You just need to know how they look like. So mostly for identities, you will be asked to prove if something equals another and so on and stuff like that. Or you need to know what something can be summarized to. Okay, you need to know what something can be summarized to. Right, so without any waste of time, let's get into it. We are going to look at your quotient identity. Without any waste of time, let's look at it. So we're looking at the quotient identity. Now, I want you to consider, of course, in your Cartesian plane, I want you to consider the point here with coordinates x and y. And let's say it's elevated at theta degrees. Okay, so you can draw a right angle here, right? You can draw a right angle here. And remember, this is your Cartesian plane, right? This is your Cartesian plane. So what you know, this point here is what you refer to as the x, while this one here, you refer to it as your y, right? Now, what you know so far, if you are looking at sine theta, your ratio sine theta, you know sine has always been or is always opposite over hypotenuse, right? Opposite over hypotenuse. Allow me to call the hypotenuse r. Okay? So when you look at it, the side that is opposite angle theta here is this one here, which is y units long, right? So it's y. And what is the hypotenuse of this right angled triangle? It's r. Okay? It's r. Now let's go to cos theta. You recall from grade 10 that cos theta is adjacent over hypotenuse. What is the adjacent? It's this side here, which is x units long. What is the hypotenuse? Hypotenuse is r. It's r units, right? Then we then go to your tangent. So your tan theta is again opposite over adjacent, right? We have said opposite side is y, adjacent side is x. Okay? So there is something that we know. There is something that we know. From here, we can see that we can say y is equal to, can you see that? Y is equal to r sine theta. Can you guys see that? In the same way, we can say x is equal to r cos theta, right? We can say that, isn't it? So we said tan theta is equal to y over x. We can therefore say tan theta is equal to r sine theta over r cos theta, isn't it? When you look at it, the r's are cancelling, what are you left with? You are left with tan theta is equal to sine theta over cos theta. Okay? So when we are dealing with a unit circle, tan theta is equal to sine theta over cos theta. All right? So this is the first identity. So whenever you see sine theta or sine over cosine, you can equate it to tangent. Okay? All right. Moving on. We will then head to the square identity. We will then head to the square identity. Okay, so with the square identity, again, let me copy that. Cannot copy it. Let me just draw it. It don't require me to copy the others that I don't need. Let me just put it here. This is y. This is x. This is x. So this point here is x and y. It is elevated by theta degrees. So we have a right angled triangle. Here is it. And we said this is r. So what you know, using Pythagoras theorem, you know that x and r squared, right? R squared equals x squared plus y squared. This is Pythagoras, right? This is Pythagoras. Now, what we have said in the previous slide, if you recall, we said y equals r sine theta, x equals r cos theta. Do you guys recall? Let me write it here. We said sine theta equals y over r. This implies y equals r sine theta. Okay? Again, we also said cos theta equals x over r. From here we can say x equals r cos theta. Right? Perfect. So now let's proceed. R squared equals, what is x? It is r cos theta close square. What is y? Remember, put it in a bracket. It is r sine theta. Now square it. What do we have? We have r squared equals, this will become r squared cos square theta plus r squared sine square theta. Right? Now, as you can see on the right hand side, we have a common factor r squared. Right? We will be left with cos theta plus sine theta. So as you can see, we can divide by r throughout. We will therefore be left with 1 equals cos square theta plus sine square theta. Right? 1 equals cos square theta plus sine square theta. Alright? Okay, so summarizing these now, let's summarize them. We will say sine square theta plus cos square theta is equal to 1. You can also play around it and make sine square subject of the formula or cos square subject of the formula. In other words, you can say this also implies sine square theta is equal to 1 minus cos square theta. Or it can also mean cos square theta equals 1 minus sine square theta. This is the identity you need to know. Secondly, Another identity was tan theta equals sine theta over cos theta. Okay, so these are the identities that we need to know for now in grade 11 and forever, of course. Now let's try to do some examples. So I will say this is example 1. It says reduce to 1 trigonometric ratios. Reduce to 1 trigonometric ratio. Okay, reduce to 1 trigonometric ratio. What are we reducing? These sine theta over cos theta. Number 2, we will try cos square theta tan square theta plus tan square theta sine square theta. Right? Perfect. Now, number 3, we will try 1 minus cos square theta over cos square theta minus tan square theta. Okay, so they say reduce to 1 trigonometric ratio. In other words, you must have only 1 trigonometric ratio in your solution at most. Okay, so now our solution, let me look at number 1. Number 1, you have sine theta over cos theta. We will not waste time. Whenever we see sine theta over cos theta, we will call it tan theta. So we are done with number 1. Right? We are done with number 1. Sine theta over cos theta is equal to tan theta. This is the information you derived. Right? This is the information you derived. Okay, moving on. We then need to go to number 2. Number 2, we're looking at cos square theta tan square theta plus tan squared theta sine squared theta. Trust me, when you look at this, I see here there's a common factor, tan squared theta. Why not take it out as a common factor? Take it out as a common factor. What are you left with? You are left with cos squared theta plus sine squared theta. What did you say cos squared theta plus sine squared theta becomes? We said it is equal to 1. Therefore, our answer is simply tan squared theta. Okay? Or you can do that. You can do this, which I don't think it's important. You can do this. Just say cos square theta tan square theta plus tan square theta sine square theta. And say, okay, cos square theta, wherever I see tan, I will say it's sine over cosine, right? However, it's a square, so it will be sine square cos square plus, again, sine square over cos square theta times sine squared. What do you see now? The cosines are cancelling. What are you left with? You are left with sine squared. You are left with sine squared theta plus sine squared theta times sine squared theta will be sine 4 theta all over cos squared theta. okay, all over cos squared theta. Okay? All right, so now because this is a fraction, we have to simplify this. So let's continue. This will become cos square theta times sine square theta. So in other words, it will be cos squared theta sine squared theta. Is it minus or plus? Okay, plus sine to the 4 theta all over cos squared theta. All right? As you can see, you have a common factor here, which is sine squared. Take it out. You have sine squared theta taken as a common factor. You are left with cos squared theta. And then what are you left with here? You are also left with sine squared theta all over cos squared theta. Now what you know, sine over cosine is tan. However, this is sine square over cos square, so it will be tan squared. Now, cos squared theta plus sine squared theta is equal to 1. This will become tan squared theta. Okay? So it's up to you as to how you want to do this. All right? All right. Now, number 3, let's see. Number 3, we have 1 minus cos squared theta all over cos squared theta minus tan square theta. What do we have? 1 minus cos square theta is equal to sine square theta. Remember, we have said that cos square theta plus sine square theta is equal to 1. So sine square theta will be equal to 1 minus cos square theta. So here we will say we have sine square theta over cos square theta. I'm not going to change this tangent as yet because I see I have tangent here. So allow me to leave it as tan square theta. So what is this? This is tan square theta minus tan square theta. This will become 0. It's okay. It will be 0. It's okay. Right. Now, let's try example 2. Example 2 will be about proving identities. Example 2 will be proving identities. So prove the following identities. Number 1, we will consider 2 sine theta cos theta all over sine theta plus cos theta is equal to sine theta plus cos theta minus 1 over sine theta plus cos theta. Number 2 will be cos theta over sine theta plus tan theta close all multiplied by cos theta is equal to 1 over cos theta. Okay? Perfect. Number 3, it will be cos theta over 1 plus sine theta plus 1 plus sine theta all over cos theta is equal to 2 over cos theta. And then the fourth one, we'll just do 4, will be open bracket cos theta plus 1 multiplied by cos theta minus 1 close bracket must be equal to 1 over tan square theta cos square theta. Right? Okay. All right. Now, this is it. Now let's get into it. Let me change the color. Now, when you prove identities, what you need to look at is this. You need to consider which one of the left-hand side or the right-hand side is the most complex. And then you choose the one which is easier to break down. Okay? You choose the one which is easier to break down. For example, it won't be easy. Let's look at number 1. Let me write it down. Number 1 was 2 sine theta cos theta is equal to sine theta plus cos theta, which is also equal to sine theta plus cos theta minus 1 over sine theta plus cos theta. So what you do, you look at the one which is easy to break down or easy to simplify. You know, when you go step by step, you can simplify it. And that one is the left-hand side. So at the end, we must prove that the left-hand side is equal to the right-hand side. So in this case, we will say left-hand side equals, you write it as it is, sine theta plus cos theta minus 1 over sine theta plus cos theta. As you can see, we have the lowest common denominator, which is sine theta plus cos theta. So everything here will be multiplied by the lowest common denominator. Okay? So let me just say it here. Else, so let me just say LCD is sine theta plus cos theta. This is for your attention. Even if you don't write it down, it's okay. All right? So this is equal to, meaning we will multiply this by LCD, this by LCD, and this we cannot multiply by LCD. So we will say we have sine theta multiplied by sine theta plus cos theta plus cos theta multiplied by sine theta plus cos theta minus 1. All these are over sine theta plus cos theta. Now what do we have? We have sine theta times sine theta is sine square theta plus sine theta cos theta. Sine theta again plus sine theta cos cos theta. Alright? Now sine cos theta times cos theta will be plus cos square theta. Of course, we also have the minus 1. Alright? All these are over sine theta plus cos theta. Now, connecting like terms, you have sine theta cos theta plus sine theta cos theta. You also have sine square theta plus cos square theta. This must be 1. So, first and first, sine theta cos theta, we have 2 of them. Our answer will be 2 sine theta cos theta plus 1 minus 1. Remember, this plus 1 comes from sine square theta plus cos square theta. And of course, this minus 1 is there. All over sine theta plus cos theta. All right, perfect. As you can see, 1 minus 1 is 0. You are left with sine 2 theta cos theta all over sine theta plus cos theta. And is this what was not the what was the right hand side? It is. So in other words, the left hand side is equal to the right hand side. And this is how you prove identities, okay? This is how you prove identities. Right. Proceeding to number 2. Number 2, we look at cos theta over sine theta plus tan theta. All these will be multiplied by cos theta. They are equal to sine theta. The one that is easy to break down is the left hand side. All right, it's the left hand side. So we'll say the left hand side is equal to cos theta over sine theta multiplied by tan theta, all of them multiplied by cos theta, isn't it? All of them multiplied by cos theta. So what I would advise that you do is this. This is tangent. So I would advise you do the following. Say cos theta over sine theta plus sine theta over cos theta, all multiplied by cos theta. Now what you see here, you have what we call the lowest common multiple, which is sine theta cos theta. Right? So what this will do will mean that your denominator is sine theta cos theta. Now you will say cos theta, okay, and then lowest common multiple divided by the denominator of this fraction. This means you will have cos theta times cos theta plus, this is sine theta. You will say lowest common multiple divided by the denominator of this fraction, which is cos theta. So if you divide this by cos theta, you are left with sine theta. Do not forget they are all multiplied by cos theta. Okay? Proceeding, it means we have cos square theta plus sine square theta all over cos theta sine theta, all multiplied by cos theta. Now let me show you something. This cancels with this. Now what are you left with? You are left with this. We know this identity, the square identity, we know it is equal to 1. Now what are you left with? You are left with sine theta. Let's see. Yes, it is equal to the right hand side. It is equal to the right hand side. All right? It is equal to the right hand side. Okay? So we're able to prove this identity. Now, let's then head to number 3. This is interesting. Number 3. So with number 3, we had cos theta over 1 plus sine theta plus 1 plus sine theta over cos theta, which is equal to 2 over cos theta. The one that is easy to break down is the left-hand side, which is cos theta over 1 plus sine theta. Yes, the left-hand side is easy to manipulate, right, all over cos theta. So here you have, because you have dissimilar terms in the denominator, you will use lowest common multiple, which is 1 plus sine theta multiplied by cos theta. Okay? Multiplied by cos theta. multiplied by cos theta. So you will then say your lowest common multiple, you write it in the bottom, 1 plus sine theta multiplied by cos theta. Now cos theta multiplied by its denominator is 1 plus sine theta. Its denominator is 1 plus sine theta. So this lowest common multiple divided by 1 plus sine theta will leave you with cos theta. So you multiply this cos theta by that cos theta that's remaining. Plus, again, 1 plus sine theta. Again, you will divide the LCM with the denominator here. When you divide the LCM with the denominator here, you will be left with 1 plus sine theta. Proceeding, we have cos square theta plus, using the FOIL method, this will be 1 plus 2 sine theta plus sine square theta all over, let's see, 1 plus sine theta multiplied by cos theta. All right? Oh yeah. Okay. So before going to the next page, I want you to see something. We have cos square theta plus sine square theta. We know this square identity is equal to 1. Okay. That means we have 1 plus this one here plus 2 sine theta all over 1 plus sine theta times cos theta. Now what is this? This is 2 plus 2 sine theta all over 1 plus sine theta times cos theta. As you can see in the numerator, we have a common factor 2. We are left with 1 plus sine theta. In the denominator, we still have 1 plus sine theta multiplied by cos theta. As you can see now, the 1 plus sine thetas are cancelling. We will be left with 2 over cos theta. And this is equal to the right-hand side. This is equal to the right-hand side. Right? This is equal to the right-hand side. Okay? This is equal to the right-hand side. Proceeding. Let's check number 4. Let's check number 4. Oh, number 4. Oh, for me, it's intimidating. I won't lie to you. Number 4 is intimidating for me. I don't even know where to start. But it's okay. It's okay. All right, number 4. Number 4 was 1 over cos theta plus 1 all multiplied by cos theta minus 1 is equal to 1 over tan square theta cos square theta. Oh, I do not think that the left-hand side is the one that I can simplify further. I generally do not think so. I honestly, in fact, do not think so. So I will think the left-hand side is the one that's complex. But it won't be easy for me to simplify the right-hand side. Therefore, I will take the right-hand side. The right-hand side is 1 over tan square multiplied by cos square theta. Tan square theta multiplied by sine square theta. What we know that sine, its identities, Tangent, its identity is sine over cosine. So sine square theta over cos square theta, then multiplied by cos square theta. All right? Perfect. Now, what you can see here, you have these are cancelling. You are then left with 1 over sine square theta. Now, you have sine square theta. This is not what we are looking for. However, you remember the square identity, right? You remember the square identity. Sine square theta plus cos square theta is equal to 1. So if you make sine square theta subject of the formula, you'll be left with 1 minus cos square theta. This therefore implies we must say 1 over cos, 1 minus cos square theta. So I think here there is a mistake that I made. This is supposed to be, let me see, it's supposed to be minus, okay? It's supposed to be negative 1 over this. It's supposed to be this, okay? It's supposed to be this, I think, but it's okay. Let me continue. It's supposed to be that. We will see later. Okay. So we were able to prove that this is indeed the case. All right. So we're supposed to prove cos theta. When it's like this, there is totally no way where we can say cos is positive. Hence, I thought this is supposed to be negative. All right. Hence, I said I think this is supposed to be negative 1. Okay. Hence, I said it's supposed to be negative 1. Okay. It's supposed to be negative 1. So, continuing, let's see. Continuing, it will be, this is a difference of 2 squares. So maybe let me take, because I see cosine is supposed to be, the cosines are supposed to be positive, but the 1 is supposed to be negative. All right. This is the difference of 2 squares. So I will do the following. Turn with me. 1 over negative open bracket cos theta, let me see, cos theta minus 1 close bracket. Okay, it's supposed to be like that. Now as we continue, this will then become negative 1 over, cos square theta, not cos theta, cos square theta. Let me fix that. Cos square theta minus 1. So as we continue, this will be negative 1 over cos square theta minus 1. And then this will become cos theta minus 1. And then cos theta plus 1. Okay? So with this, it will mean that we have proved that the right hand side is equal to the left hand side. It's equal to left hand side. This one's the right. Is equal to left hand side. Let's see if there can be any mistake from our side. From our side, there is totally no mistake. So it's okay. This was supposed to be minus 1 over cos theta plus 1 all over cos theta minus 1. I think it's okay like that. So with that being said, it's a wrap, and I hope you guys will now be able to master this thing of identities in your examinations. Okay, so with that being said, it's a wrap, and do not forget to subscribe, like, and comment. Also, share with your friends. So, Bye bye.